But this time, what I'm going to do is we are going to use XLSTAT to work on it. Right, okay, so I know you guys probably have already tried out XLSTAT, for project 1, and in case you haven't, I want to show you a little bit so you can see how this can be done. Okay, so the same question, okay, the same, somewhat similar question, so let's see. Okay, so what we have here is based on a sample of 35 observations, and so you were asked, is the premium rate justified? So if you look carefully, you probably realize, okay, sigma is not given here, right? We don't have that information. You know, previously was saying, you know, assume sigma is false, something like that. Over here is not a given. All we have is sample information. So that means based on this sample information, we can calculate the sample mean. We can probably also calculate sample standard deviation. If we only have sample standard deviation, what kind of test is it going to be? Is it going to be a z-test then? Is it going to be a z-test?
It's a t-test.
Yes, it's going to be a t-test. You're absolutely right. So great. Thank you for answering that question. Okay. So it's going to be a t-test, right? Okay. I'm going to show you guys how this do. You know, we don't have sigma, so we have to use a, well, I'm not sure why this is okay, we have to use a t-test. We use XLSTAT to carry out this t-test. Okay, so all the steps are given here. They are all given here. I'm just going to do a demonstration. So first is okay, so I'm using a Mac at this moment, and my office computer is a PC. So so if you have some, you know, if you have some difficulties, you can also check with me, because I'm fairly familiar with the PC version of XLSTAT, but they look somewhat similar, to be honest. So the first thing is I have the data. You want to take a look at the data we have. I think it's 35. I'm just going to clear this one out, clear the contents. I'm going to zoom in a little bit because I know it's a little bit small for you guys to see. Okay, so we have 35 observations. You can see it here. I think it stopped at 36. Yes, it stops right here, 36. Okay, so this is the data we have, 35 surveys, and we want to use XLSTAT to carry out this test. So the very first thing is you're going to click on XLSTAT to start it. Okay, so you can see a bunch of ribbons here. And the test we are doing here is a one sample t-test. I think Benjamin told us it's a t-test, and one sample. This is actually in comparison to two sample, which we're going to talk about right after midterm. Okay, so first things you want to click on parametric test. All this instruction, all the detailed steps are given in the handouts. And typically if you work on the project, so I will give detailed steps as well. So one sample t-test, you click on here, you can see there's a two sample, but we are working on the one sample one. Okay, so you have a dialog box. Okay, hopefully you guys have already played around with XLSTAT. So the very first thing I typically like to do, the very first thing every time I do XLSTAT is I like to reset them. You know, click here to reset a dialog box, to reset everything. Okay, and you would have to tell XLSTAT which data you're working on. The data we have is here. Okay, so I'm gonna do is I'm just gonna click on here. And some other time you may be able to click on here, you know, try to change it. So this mouse means I'm gonna use my mouse to select it. Some other time if you click on here, you can see there's like a something like a spreadsheet here. If you click on that, you can click here and then there's a time, you can select it. So there are two different ways of selecting. I'm just gonna do it twice so you can see how I do it. Okay, so let me just show you. And so yeah, so two ways to do it. I'm gonna demonstrate. If you click on here until you see this dialog, like a Excel spreadsheet, things like, if you click on here and then you can choose time, okay. Alternatively, you can change it to mouse. You can choose this one. So it all work equally. And make sure the data format is one column per sample, because we only have, this is our data per column. And typically there may be a header here, as you know, we have a data here. So make sure your column labels is checked. Make sure it is checked. And the test we have is a student t-test. You may be wondering, why is it called student? Okay, So T distribution, when they first started, is actually called a student T distribution. The reason is because the person who started, I just actually Google it out, Wikipedia. Wikipedia has everything we need. The person is called William Gossett. So he established, he started the T distribution under a pseudonym. So he called himself a student. You can call yourself student as well. So typically the distributions can be named after the person who started. So because he used a pseudonym instead of his real name, so everyone's followed him and called that's going to be a student distribution. Later on, they changed it to student T distribution. But this distribution actually came from William Gossett. Okay. So I think I've already changed this one. Make sure you reset. Options. Okay, so you have a bunch of options. So you were asked what kind of alternative hypothesis you have. So do you remember what is the alternative hypothesis we have? Was it a two-tail test, a lower tail, or maybe upper tail test? I think it was an upper tail test, right? You remember? Okay, we want to see whether it is more than 15. I think it's okay. And then you were asked what is a theoretical mean? This is nothing but a mu0. I think we were comparing with 15, so I'm going to change it to 15. And you were asked what is the significance level? It is 5. I'm just going to leave it as it is. Missing data, you don't have to do anything. Outputs, make sure all of them are checked. Charts, I like to check this one as well. You can click OK, and XLSTAT is going to run, and then you're going to get an output, right? If you look carefully, this was the original data. Hold on a second. This is our original data. When you run an XLSTAT, all the results is going to be displayed in a new tab, new sheet. Okay, so I'm going to zoom in a little bit for you guys to see it clearly. So there are 4 ribbons here. Okay, I like to use the second one. This is going to clear out all the gray lines. So it's much cleaner, right? You guys agree with me? And you can go down a little bit, scroll down a little bit. So you can see this is the output. But you see some of the names are distorted. I wouldn't say distorted. There's not enough space. So I'm going to just move it a little bit, drag it a little bit. So to make sure everything is displayed here. Okay. So this actually tells you what is the, so this one. Okay, hold on a second. My computer is running a little bit slow, so it doesn't respond. Okay, so this is T. This is nothing but our T-score. So this is our T-score. It's a 2.611. So you don't have to do any calculation. You don't have to do all the formula plugging. No, you don't have to do that. 2.611 is the test statistic. And you were also given the critical value right away. So this is your cutoff value, 1.691. You also have the degrees of freedom. You also have the p-value, as you can see here, right here, right? You don't have to do anything. And XLSTAT also tells you this is your null, this is your alternative. And what's super useful is the next plot. This is the distribution. Remember, I checked the distribution. So this distribution, when you check that distribution box, you're gonna have this plot. This plot actually says, okay, so let's take a look. This plot actually, is fairly similar to the bell curve I drew earlier on. Okay, so this plot actually says, okay, so this plot actually says this part is the null. So this is H0, okay. And this is our test statistic. This is the evidence from our, unfortunately, I'm not on my iPad. Wow, this is terrible. Okay, I'm not going to try. So this is our test statistic. Over here, this is the critical value, right? This is a C.V. The test statistic is to the right of this critical value. So again, you reject it. You can reject it. So this is, the conclusion you get using critical value. If you use the p-value approach, you can also see it here. The p-value is 0.007. This is less than alpha. So again, you also reject it, right? So 2 different approaches, you can get the same conclusion. XLSTAT also tells you p-value is lower than alpha, so you can reject it, right? We should reject, right? So this is how you carry out a test using XLSTAT. Okay, let's see. So for exercise 1, it was a z-test, right? What kind of test do we have here? This is a t-test, right? So if it's a t-test, that means you probably have to use a t-table to find a critical value. And you have to use a degree of freedom, which is sample size -1, that's 34. The same information you can see here, right? So that's why the critical value is also different, right? Sorry, very different, right?